To conduct a t-test, you need one nominal independent variable with two categories and a scale-dependent variable. I'm going to start by loading up my data. And again, my data is appearing here in the recently opened tabs, but if you need to navigate your data set, you can do so through computer. And once you open the Silk data set, the tab we're going to work with in this video is up here, the t-tests. And again, as with all the others, there's a frequentist and a Bayesian version of each, so you just want to make sure you stick with the top one. We're going to look at the independent samples t-test. The paired samples t-test is generally for experimental or time series data, which we don't have, so we're going to work with the independent samples version. And as soon as you click this, you are taken straight to the variable entry screen, the settings screen, and also the results window. So the independent samples t-test is used to test for equality of means, or to put it a different way, if the mean of a given variable, a scale variable, differs between categories of an independent variable. The classic version we looked at for this test using individual level data was whether income differs between genders, between male female as measured in the EU Silk. What we're going to test for today using household level data is whether there is a difference in mean household income between those households in an urban or a rural area. If your project involves something to do with, say, regional comparisons, or indeed if you're looking at a study of poverty, one thing that we do know is that there are some important differences between urban areas and rural areas in terms of economy, employment, and so on. So the first thing we're going to do is we're going to just make our selection for households, and we're going to do that using the filter tab. I want to make sure we're dealing with the first person, so person number 1, as we saw in the previous video, and we're going to limit ourselves to households with a disposable income above 0. So make sure that's greater than, and then we're just going to click here and type 0. Apply the pass-through filter, and now we are dealing only with households. When you're finished, you can close that down. So returning to the test window, I'm going to scroll down, and again, the grouping variable is the field where we're going to transfer over the independent variable. And remember, for the t-test, this variable should have only two categories, so gender, male, female, location, urban, rural. We looked at others such as part-time, full-time, and so on. For independent variables with two groups, we use the t-test. For those with those with more than two groups, we're going to use one-way ANOVA, which we'll look at in the next video. So it's not too far down the list here. If we scroll down, you'll see that we've got this variable, we're going just down here, called URB_RUR, and that measures whether the household is in an urban or rural location. Click on the variable to activate, and then we transfer it over to the grouping variable box using this arrow. The dependent variable in this case is going to be household disposable income, this nat_disping variable over here. You can transfer over as many variables as you want, and the test will just repeat with different dependent variables. Obviously, farm income would predominantly be rural anyway. But if you wanted to look at, say, perhaps a different income concept, or if you wanted to look at something like investment income or property income and so on, you can just transfer over as many as you want, and the test will repeat itself in the rows for as many variables as we have in this box. But we're just going to look at the case of disposable income first of all. So there's not too much to write home about in the test screen once we transfer the variables over. That's because we're going to want to activate some more things down here. Now, if you remembered the interpretation of the p-value, one little thing about JASP that you need to recognize is that for very small quantities, it will write the results in scientific notation. So this is 2.81 times 10 to the minus 7, which is basically, so we add, after the decimal, there's an additional, before the decimal, there's an additional 7 places, so it's 0.000002 and so on. So what we want to do is to add some additional fields. We want to look at the effect size, the descriptives, and also activate this plot here. And we're actually going to start by looking at the plot. So once we activate these things, you'll see here that we're given a graph that shows us the difference in mean incomes between urban households and rural households. We've also activated the descriptives table, which is this one here. So if we look here, you'll see that it's showing us a mean income of 48,000 for urban households, which is graphed here, and a mean income of 42,000 for rural households, which is graphed here. So we get a nice little visual of the difference between those two. We also get the standard deviation and the standard error of the mean. The result that we're looking for, again, is our p-value, and because we're into this 2.81 by 10 to the minus 7, it's quite a small figure, much far below 0.05. And we also have added this option here for the effect size, which is Cohen's d. So again, this is interpreted the same way, roughly the same way, sorry, as we would have interpreted Kramer's, but also R. So it ranges from 0 to 1, and all those gradations in between that measure whether the effect is very small, moderate, or strong. So in this case, we have a statistically significant difference in mean incomes between urban and rural households. The size of that difference we can see here illustrated in the plot, and the effect size is small to moderate. So again, and looking here at these figures, we see it is quite a consequential difference. We have a difference of approximately 6,000 euros per annum in terms of those two groups. So if you want to repeat this test using different variables, then it's simply a matter of swapping out the variables and including the dependent variable of interest. If we were doing a test, and again, if you are doing an example with, or if you're testing an hypothesis with individual level data, you should go back and make your setting for individuals using the procedure that we've looked at before, and also using the filter window, but I'm just going to do it with the household setting active. So let's say we wanted to test for a gender difference. That simply involves moving the gender variable over to the grouping variable, and there's several measures that we could look at. We could look at personal incomes, we could look at different components of income, we could also look at working hours. So we're just going to go down through this list and see if we can find some individual level income measures. The most obvious ones probably are the individual level income variables, but there are also measures of hours worked. This is hours worked in primary job, hours worked in secondary job. So you'll see there quite quickly, by transferring these over, the results snap in automatically. So here we have an illustration of a test of the difference in mean hours worked between males and females. It's illustrated here on the graph, an average of 39.97 for males, 30.44 for females. Again, some of this can be explained by the predominance of part-time or non-standard employment amongst females, but it is a substantial difference. The difference is statistically significant, p is less than 0.05. The effect is relatively strong, and we can see in real terms the difference in actual hours is quite large. It's a difference of just under 10 hours. So we can test for different variables. You can leave this one in if you want, or you can select them. You can take it out and then transfer over another one if you wanted. So if we wanted to look simply at disposable income, I think we've already looked at this example already. We can transfer disposable income over to the variables window, and now you'll see that JASP automatically changes the scale of the plot. So this now is in euros. And the difference in income between males and females is again quite large, difference of 22,000 to 31,000. The result is statistically significant, and the effect is kind of small to moderate. So again, remember, this will change slightly when you adjust the settings and the filters in the previous screen. But nonetheless, that's how to conduct and interpret the independent samples t-test in JASP.